Okay, it is time for us to talk about permutations and combinations. And we have just finished a video talking about factorial. And that factorial is important because we're going to compare and contrast factorial to permutations and combinations. So if you haven't watched the previous video, please go back and watch it. So as a quick reminder, factorial, okay, I'm going to put this over here. Factorial is when you have 5 objects and you want all of the objects in order. So let's say you're on the game The Price is Right, and they give you 5 numbers in the price of the car, and your job is to put those numbers in the correct order from first to last. Well, you're first going to start with the first number in the price of the car. That would be 5 choices, because let's imagine that they give you the 5 numbers. They're not just like pick a number from 0 to 9. The numbers are scrambled. The 10 chances game is one of these games that does this. So you can look that up if you want. So you pick from the 5 numbers and hopefully the correct first number in the price of the car. And then you will pick from the remaining 4 numbers the price of the car. Then the remaining 3, and then the remaining 2, and then the remaining 1. Now, if you multiply 5 times 4, which is 20, times 3, which is 60, times 2, which is 120, times 1, which is 120, there are 120 ways to do this problem. Which means that if you're playing the 10 chances game, randomly picking from those 5 numbers, you would need actually 120 chances to actually make sure that you get the price quite right. Now, hopefully you have some pricing knowledge and wouldn't put a 9 or an 8 as the first number of the price of the car, so maybe you can do a little bit better than 5 times 4 times 3 times 2 times 1. But this is the idea of factorial, taking all the numbers from your set and guessing them in the correct order. Permutation is not that way. Permutation is answering the question, how many ways can I choose some items in order? Okay, not ode, odor. Order. Odor? Order. Some items in order. Okay, so compare and contrast. Permutation is some items in order. Factorial is all items in order. So permutation should be smaller. And let's actually make this game on The Price is Right a little easier. What if instead of having to get all 5 numbers in order, you just had to get the first 3? So what this means is you have a 5 pick 3 in order situation. A 5 pick 3 in order. So what you would do is you'd have to pick the correct one, so you'd have 5 choices here. And then hopefully you would be able to pick the correct second one, which is 4 choices. And then pick the correct third one, which is 3 choices. 5 times 4 times 3. And if we multiply these together, 5 times 4 is 20, times 3 is 60. So you can see that your chances of getting it correct is much easier now, only having to pick 3 instead of picking all 5. Now it's time to bust out the permutation notation. Okay, now what you probably saw is that if you're doing a permutation, you start with how many there are in the problem and you go 1, 2, 3 times. See? 1, 2, 3. So you can see that we actually did part A right here. So if we're going to do part B correctly, we would go 7, 6, 5, and then 4. Okay, so we're picking 1, 2, 3, 4. Sometimes people think that this second number on the permutation, which also you can maybe lazily think is the word pick, but some people think that this number here is the number we stop at. And so let's look at part C right here. This is 6 and 5. 6 times 5. So we're not actually stopping at the 2, we're picking 2. So you see we picked 1, 2, 3, 4 here, 7, 6, 5, 4. And here we're picking 2, 6, and 5. All right, so we will get to part D here in just a moment. But I also wouldn't be a good math teacher if I didn't give you the permutation notation. The permutation notation is NPR, which is N, your sample size, your P for permutation, and your R, which is how many picks you get to make. And this is the N factorial divided by N minus R factorial. Now, if you understood everything I said up here in green, what I'm about to do in part A in blue, you can kind of maybe take notes on it, but, you know, for some, this would be your advanced algebra portion of the notes. Because N factorial in this case is 5 factorial, and the denominator is 5 minus 3 factorial. Notice that the factorial is outside of the parentheses. So if we simplify this, this would be 5 factorial over 2 factorial. And then if we write the numerator out as 5 times 4 times 3 times 2 factorial, notice I just stopped here instead of writing 2 times 1. The denominator is 2 factorial, and now I can do some simplification. I know you guys call it canceling, but I'll say simplify. And now I have 5 times 4 times 3, which is a total of 60. Okay, so in part B, well, I can multiply all these out on a calculator, which I'll easily do by turning on my calculator and going 7 times 6 times 5 times 4. And see, I get 840. But why don't I try hitting 7? And instead of hitting multiply, hit the math button. Then move over to probability, which is over in this menu setting. And you'll see that option number 2 is NPR. And I have my calculator in classic mode, so my NPR is right between the 7, and then I'll type in a 4, which means I want to rank my 4 best choices from a group of 7. And there it is, 840. And you can see I can go 5, and I can go math, and I can go to probability and go to NPR, and then choose 3. And that'll give me my 60. Okay, and if I do the same thing by hitting second enter and just kind of moving my arrow back, I can go 6, choose 2, or 6, pick 2, and I get 30, which is 6 times 5. Okay, so let me write these answers down here. This is 840, and this was 30. Now, if I have 7 items, and I want to choose 7 of them in order, that's the same thing as 7 factorial. Because according to the formula, I would have 7 factorial divided by 7 minus 7 factorial, and that leaves me with 7 factorial divided by 0 factorial. And we learned from the previous video that 0 factorial is 1, so this is just 7 factorial, which I don't want to type all the way in, so let's just type in 7, math, probability, and number 4. 5,040. So this answer is 5,040. 7 factorial, choosing 7 items in order. Okay, so now I get to talk about my favorite thing, the locker problem. Okay, so remember back in middle school? True fact, I actually was at a middle school for 8 years as a middle school math teacher. And one of my assignments every year was a homeroom. And I had 15 to 30 students in that homeroom. And in the homeroom, we all had lockers. And it was my job to keep track of those 15 to 30 students and get them some locker work. Because, man, did they have some trouble, right? Now, think back to yourself, man. Do you remember how many numbers there were on a locker dial? If you have good memory, the answer is 40. Okay, the answer is 40. The lowest number was 00, and the highest number was 39. 8 years of helping students do those lockers. We want to pick 3 numbers. And the reason why we want to pick 3 numbers is because those 3 numbers represent the first, second, and third number they would have to get correct in a locker problem. Now, I will say that in the true form of this problem, you could repeat a number, but you don't actually, you can't repeat numbers in locker problems like this because the way that a lock works, it needs to have at least the middle number be different from the front number. So we're going to kind of just ignore the complexities of this for a moment and just see this as what it is. This is a simple locker problem where if some student came up to me, and I can't tell you how many times this happened, Mr. Anderson, somebody stole something out of my locker. Well, that absolutely did not happen because the person who had to steal the thing from your locker had to pick the correct number out of 40 different possibilities and then pick the second number out of 39 different possibilities and then 38 possibilities after that. And again, we're ignoring the fact that the first and the third number could be the same in this locker problem, but we're going to just say it doesn't, okay? Well, there's a lot of ways to do this, isn't there? I mean, I could just multiply these 3 things. I could go 40 times, whoops, not minus, times 39 times 38, which is 59,280. Or I could just go to my calculator and go 40 math, probability, permutation, and then how many are we choosing? We're only choosing 3, so still 59,280. Or we could use the actual formula here, which is the same thing as 40 factorial divided by 40 minus 3 factorial, which is 40 times 39 times 38 times 37 factorial divided by 37 factorial, which simplifies, you would say cancel, to give me my answer of, and I already forgot the number, 59,280. So, 59,280. Almost all situations when a student said something was stolen out of my locker, here's what really happened. Number 1, it was actually in their locker. They just didn't look hard enough. Number 2, they share lockers with somebody and forgot to put the thing back into theirs because they had it in their friend's locker. Or 3, they short locked, which means you do all 3 numbers but don't lift up on the lock so you can look cool and walk by your locker and just lift it up between classes. So, nothing was stolen out of a locker. Okay. So what do we call those things? You've been through this locker problem with me, and I've been avoiding a word that many of you use to talk about this situation, because you call it a locker what? What do we call for the 3-digit code in a locker? Yup, you know the word that you're thinking of is a locker combination. Well, I got some bad news for you, because this is literally a locker permutation. That's right, the locker problem is the fact that everybody who's been talking to you in your adolescence through your teenage years, we've been using the wrong word. The correct word is permutation, because a permutation is some items in order. We have locker permutations, not combinations. We don't have locker factorial because we're not trying to dial in all 40 numbers. Imagine memorizing that as a 6th grader. Woof. So let me get this straight. Is it true that locker permutation is correct? Yeah, sure. Look it up in the dictionary. Webster.com, right? What about combination? Well, I got some news for you. We are going to define combination. And combination is not what we do with a locker, because a combination answers this question: how many ways are there to choose, almost, I don't know why I wrote a T there, to choose some items without order. Without order. All right, so I'm going to clean up that O there since I'm going to look at it the whole video here. All right, that's what a combination is. And you might be thinking, no way that can be right, but look it up in the dictionary, Webster.com. You literally look it up, and a combination is defined at picking some items without order. Yeah, I know, blows your mind, right? It's like when you go to a locker, you won't look at it the same way ever again. A combination is choosing some items without order. And it is unfortunate that I am going to have to lay right now on you the combination notation. But let's actually start with a story problem here. The combination notation starts out something like this. Say you have a suitcase and it's filled to the brim with everything you need to bring on the trip that you have to bring on the trip. You know, such things like the minimum amount of spare clothing, your important medications and prescriptions, and toiletries, okay? So you don't have to buy the expensive travel size stuff. So you got all the necessities, and you only have room for 3 more things. So the bad news is that you don't you don't just have 3 things left to bring. You have 5 items, okay? You have 5 items, and in this case you have to choose 3 of them. And really the order doesn't matter. And the reason why the order doesn't matter is they're all getting crammed in the suitcase. So you have 5 items, you're choosing 3 of them, and you don't care about the order. All right, well, this one isn't as logical as the last 2. In fact, the notation is probably more important for what we're about to do on the calculator. You see, the notation is going to be, instead of NPR, it's going to be NCR. And the N stands for the number of items, and the R stands for the number of picks. An alternate way to see this is when one of the numbers is floating on top of the other number, and this here is 5 choose 3, and you'll see this in more advanced statistics classes and in your discrete math courses. All right, well, it's time to lay the formula on you, and it ain't pretty. It's n factorial divided by k factorial times n minus k factorial. If you had your college algebra and maybe did your binomial expansion, you've probably seen the combination formula here. But I would like to show you, before you end up doing the whole thing on the calculator, I'd like to show you how this works out formula-wise, and then, you know, for parts 3a, b, and c down here, I'll show you how to type it in. So, n factorial, this would be the 5 items you want to cram in that suitcase. But since you actually don't want all of them, you're going to go 5 minus 3, which is your 2 factorial. So now this here looks like a permutation, right? So, I mean, if you cover up the k factorial, that's permutation formula. But the k factorial is going to eliminate the fact that you're not putting these things in order. I mean, you're literally putting these 3 things in the suitcase, and you don't care which goes in first or last. You just want the 3 things in the suitcase. So there it is. You're going to divide by that 3 things in the suitcase. So let's do some 5 factorial. We go to 5 times 4 times 3 times 2 times 1. I'm just writing it all out. Divided by the 3 factorial, which is 3 times 2 times 1. And then the 2 factorial is 2 times 1. So now all the factorials are written out as multiplication problems. Now, you would say cancel, but I would say simplify. The 2 divided by the 2, and that makes 1 over 1. And then the 1 divided by the 1. And here, the 4 divides the 2 and leaves me with a little 2 in the numerator. Okay, so now instead of 5 times 4 times 3, it's 5 times 2 times 3. And you'll notice I can do just one more little canceling or simplifying there. So what I have left is 5 times 2 in the numerator and 1 in the denominator, and the answer is 10. There are 10 ways to pick 3 items without order. So your answer here is 10. Now, you know this seems pretty advanced for where we come from, so let's turn on our calculator. And look, I've covered up all that busy work there. Why would you do that? Because you can type in 10. Sorry, not 10. Whoops. You can type in 5, because we're going to do 5, choose 3, or 5, combination of 3. And click the math button and move over to the probability and then move down to NCR. And there it is. And choose 3 and voila! 10! Now we can do the next one. If we have 7 items, or how about this? I'm thinking of maybe a homework problem. Let's say you have, let's see, you have 7 pizza toppings, okay? 7 pizza toppings. And you can only choose 3. Sorry, you can always choose 4. I'm doing part B right here, so I better stick to the problem. You have 7 pizza toppings, and you can only choose 4. How many ways are there to do it? Now, the pizza guy doesn't care which one lands on the pizza first, okay? So it's just 7, math, probability, NCR, 4, okay? And there we go. 35 is the answer. There are 35 ways to put 4 toppings out of 7 on a pizza, which is pretty good. Whoa! Scroll down a little, got a little excited there. All right, so I'm going to put this here as 7 choosing 4, 35. All right, 10 choosing 6. 10 choosing 6. Time to get my calculator back. Here we go. So I've got 10 pizza toppings, and I want to know how many ways can I put on those 10 pizza toppings, NCR. And I'm choosing only 6 of the 10 for my supreme pizza, and there are 210 ways to do this, which is much smaller than doing a permutation or a factorial because the order doesn't matter. Hey, 47 choose 6? Well, ladies and gentlemen, I'm talking to you about a lottery. There's a lottery here in my home state of Michigan called the Lotto 47. It's been around a long time, and the Lotto 47 works like this. There are 47 numbers. You have to pick 6 of the 47 numbers. If you pick the correct 6 of the 47 numbers, and order does not matter, you do not care which ping pong ball drops out of that drum in any order, you will win the jackpot of $1 million or more. And just like Powerball and the Mega Ball lotteries, if people don't win that week, then the money rolls over till the next week. So, 47, math, NCR, 6. What are your chances of winning this lottery? More than 1 million. You see, the lottery's not dumb. The lottery's not dumb because they make sure that the prize is less than the odds, so you can't buy every feasible ticket. So the answer in this case is 10,757,573. 10,737,573. Let me double check and make sure I have that written down correctly. I do. Okay, so in some parts of the homework, because I know you're going to be doing some of the homework, and the homework's going to ask for a fraction, such as, what are your chances of winning this lottery? Now, these were the number of possibilities of buying, of all the 47 numbers arranged in groups of 6, without repetition. So if you are told in the homework to find the odds or the probability and write your answer as a fraction, it's as easy as putting it putting your answer under 1. Because remember from the previous video, a probability is found by what you desire over the number of possibilities. If you want to win the Lotto 47, then you want the one ticket out of the 10,737,573 tickets to be yours. So, fast fact, if you're doing your homework for this section and they ask you for a fraction, put your answer under 1 divided by. And I will erase that just because what we're doing on our worksheet right here is computing. So, let's imagine that you are at a grocery store and there are 5 rolls of toilet paper, but you only have room for 4 of them. So, how many ways can you grab 4 items out of a group of 5 without order? Okay, well, this might be a little surprising. There's only 5. And there's only 5 because if you're grabbing 4 of the 5 items, you're always going to leave 1 behind. And let's say each of these rolls of toilet paper was a different manufacturer, then there are 5 ways to leave each one behind. There's, you can leave label A, label B, label C, label D, and label E behind if you have 5 different ones to choose from. So, if you have 5 items and you're choosing 4 of the 5 items, there are 5 ways to do that, because you can imagine leaving 1 of each kind behind. Imagine, or let's put it this way. So if you have 5 different types of Gatorade at a gas station, and each Gatorade is of a different flavor, and you grab 4 of the 5 Gatorades, 1 of each, like that flavor will be left behind, and there are 5 ways to do that. But what if you're going to take everything off the shelf? If you have 5 items and you have to pick all 5 in without order, how many ways can you do that? Let me let you think about that for a second. 5 items, grab all 5, order doesn't matter. The answer is 1. Because there's only 1 way to grab all 5 items out of 5. Remember, this is not the same as a permutation 5 choose 5, because that is 5 factorial. There's 120 ways to do that. But there's only 1 way to grab all 5 off the shelf and keep it. So, we're going to end this video here trying to summarize everything you learned in this one and the previous one. So a permutation is when you need some of the items in order. Order matters. Combination is when you want some of the items without order. And factorial is when you want all of the items in order. Now, if you're curious, how come we don't have all without order? And the reason why we don't have all without order is because that answer would be 1, as we showed in the previous problem. So, what I'd like you to do is to pause this video, read these 3 problems, and try to guess which method is which. Try to guess if part A is a permutation, combination, or a factorial. Because your homework is going to be a little challenging if you can't tell what formula to use based on the story problem. So please pause and then unpause and we'll show you the answers. All right, hopefully you've tried. In the hole-in-one game on The Price is Right, you have to put all 5 grocery items in order from lowest to highest price to put the closest to the hole to win the car. To find the number of possibilities, you would use A. All right, well, kind of handy to look around and see all 5, because there's the all there. And you need the in order, so this is going to be a factorial. And the answer here would be 5 factorial, which is 120, which hopefully will be a little easier because you'll hopefully pick the candy first and maybe the detergent last. That's for my Price is Right fans out there. Okay, so the second one. A high school principal randomly picks 4 students out of the art class to help with a mural. To find the number of possibilities, you would use A. Okay, now, this one's a little bit less helpful because the high school principal is just randomly picking 4 students. Now, the word pick might throw you off a little bit because you might say, oh, pick means permutation. But be careful, because these 4 students are not ranked. So it's 4 students out of the art class, and notice there is no talk of ranking. So this is sum, and the order is not given, so this is combination. Okay. Now, I think some of you are really quick to just put the last one in here without reading it, but gosh, we should read it just in case I threw a curveball at you. You need to rank from best to worst your top 3 Beatles albums that you would like to hear. It is important to know that the Beatles made more than 3 albums. To find the number of possibilities, you would use A. That second sentence in there is to eliminate the idea of factorial, because we're not picking all of the Beatles albums because they made more than 3. So therefore, ranking is another way of saying I want order. So we want order. So it's either going to be permutation or factorial. And from the second sentence, we want sum, because they made more than 3 albums. This is going to be a permutation. All right. We did it. We got to the end of this video series on permutation, combination, factorial. Keep these notes handy, because, man, knowing those formulas and having this chart in front of you is going to be super helpful for studying for the test. Hint, hint. And as a reminder, please make sure that when you do your homework, if you have a question that asks about how many ways, give these whole number answers. But if the problem asks, what are the chances of something like what are your chances of choosing the 3 items without order, then make sure to put it under 1. So if you're, again, up here in the permutation, what are your chances of choosing maybe the 2 oldest people out of a group of 6? Well, that would be 1 out of 30. There's 1 out of 30 chances of picking the 2 oldest, because that is definitely ranked by age, out of this group. So thank you for watching, and if you have any questions, always send me an email. Thanks again.